The future of energy is shifting rapidly, with extraordinary changes behind the scenes as we move away from fossil fuels towards a flexible, clean and electrified future.
The future of energy is now. People can participate and can make their energy consumption flexible. We're very serious about building an energy future that is cheaper and greener and uses technology to back that up.
The UK has been quietly re-engineering the electricity grid for a new pattern of power that harnesses the often unpredictable nature of renewable generation.
We have 300,000 devices that are connected into this virtual power plant. That's equivalent to about 2 gigawatts of demand, which is bigger than almost any other power station in the whole of the UK.
And Octopus Energy is at the forefront of this revolution, helping to turn the traditional power grid on its head.
We are partnering with some of the UK's largest home builders to add low carbon technology into new homes that are constructed, and to do it in such a way that we as an energy company are able to offer energy completely free to the home for zero bills, zero cost of energy for 5 years.
Why would you build a house in a different way ever again?
Totally.
Hello and welcome to the new Scientist CoLab podcast, exploring the intersection of science, technology and humanity, sponsored by Octopus Energy. My name is Justin Mullins and our guest today is Kieron Stopforth, Head of Flexibility at Octopus Energy. He leads one of the most advanced teams in the UK's energy sector, pioneering demand flexibility, customer-centric energy solutions and even virtual power plants. He's here to break down the technical and real-world impacts of the massive changes to energy production and distribution in the UK, and to explain how our homes, our solar panels and even our electric vehicles are becoming active participants in a new, intelligent energy network. Kieron, welcome.
Thank you. Pleasure to be here.
Many people will know Octopus as an energy supplier to their homes, but you're actually much more than that.
That's right. Octopus was founded a few years ago with a mission to bring cheaper, greener energy, and to do this using technology. So a lot of people will know us as an energy company. So we sell energy to people across 8 different countries worldwide. We're the UK's largest energy supplier. But we're also thinking, we spend a lot of time thinking about how we can help enable and accelerate the energy transition. So we manufacture heat pumps, the Octopus Cozy. We also install low carbon technology in people's homes. And then with that technology out there in the wild, me and my team work on making it flexible and intelligent and contributing to a smart energy system.
So all of this is being generated in a way or driven by the way we produce electricity, and that is changing dramatically, or has changed dramatically over the last 10, 15, 20 years or so. How has the way we produce electricity changed?
The UK and countries around the world are seeing a massive shift towards renewable energy. So in the UK, for instance, we've moved from coal and gas and fossil intensive power stations to a more kind of balanced renewables system. So coal is now retired from the UK grid. We're not using any coal. We still have some gas, but there's a lot more renewables on stream. And this is having some interesting effects. So as recently as last month, on the 1st of July, there was so much renewables generation, the energy prices went negative for 8 hours in the day. So we have a tariff called Agile, where customers can benefit from negative energy prices and the price follows the underlying energy price. And some of the top earning customers actually got paid to use energy, earning as much as £22 in that one single day.
That's extraordinary. So you're paying them to use energy. That's extraordinary. How would they do that? What does that mean for a customer?
When you think more broadly about flexibility, flexibility is basically the ability to shift your energy use around. So that might be, if there's a lot of solar or wind generation, you can use more energy during those periods. If there are peaks on the grid in the evening, or the grid is very constrained, it might be shifting energy use out of those windows. So customers can benefit when they shift their energy around in response to these grid needs. So in the Agile example I mentioned, when prices are negative, we pass on that negative prices to customers who are on that tariff and product. We have other flexibility programs where customers can benefit from receiving free energy at times when when the price is negative, or by reducing their energy slightly.
So in practice, what does that mean? They get an alert and then they go and switch the charger on for the electric vehicle. Is that in practice what happens?
Yeah, exactly. So we have a number of different programs and different ways that people can participate. So we want to make this really easy for people to join in. I mentioned free electricity and saving sessions. Customers will get an email or an app notification saying, later on today or tomorrow, there's an hour where you have a free electricity hour. So, just go ahead and use as much energy, as you want to, shift energy into that period. And then they receive the benefit. We do the calcs in the background, and then we return that value to customers by form of a bill credit. These are fully mass market propositions. So we have about 2 million customers who are participating in flexibility in some way. So this isn't kind of the distant future. It's advanced technology, but it's here today.
And if all 2 million switch on at the same time, do you have to manage that kind of change? Do they all get the alert at the same instant, or do you have to stagger that to manage usage?
Yeah, so we work very closely with the system operator in the UK and the people who are responsible for keeping the lights on. So there are never any surprises. It's all predictable. But one thing that we do is we put a lot of effort into the data science side of things and predicting, when and how much energy people are going to be able to shift around. So, you might think if you're asking people to reduce their energy consumption, people might be doing their washing later in the evening, or they might shift their cooking outside of peak hours. If you're asking people to shift, you might think, that's a very unpredictable activity. You don't know who's going to participate and how much they're going to shift by. But actually what we're finding is through our data science methods, you can predict that with about 90% accuracy. And then that becomes really interesting because it becomes a very reliable potential resource to use on the energy system to help integrate renewables and help manage the grid.
And in order to qualify for these kinds of schemes, what kind of customer do you have to be? Do you have to have solar panels in your roof or a wind turbine in your back garden? What do you need in order to qualify?
We're trying to make this available to as many customers as possible. And for many of our flexibility programs, you actually only need to have a smart meter in your home. So with a smart meter, it's possible to tell how much energy a customer's using on a half-hour by half-hour basis. And really, that's all the information you need to see if someone made a shift or if they didn't make a shift. We have customers right the way across the sort of spectrum of our customer base who are participating in this and enjoying it. And really, it's a way, there's been a cost of living crisis and, with pressures on energy costs where they are, this is actually a way where customers can participate and see the value and actually, earn a little bit of money for participating for using energy in a smarter way.
And how often do these periods occur of free energy? Presumably you've modelled what weather conditions there are, how much capacity there is on the grid. What would people be likely to see if they signed up for something like this? So
energy prices on the grid are going negative more and more because you're seeing much more solar in the so even in sort of sunny old UK, there's still a lot of solar power about. When you have a sunny and windy day through the summer, there can potentially be hour-long stretches of periods where prices go negative because there's more energy on the system than there is energy use on the system. I mentioned the Agile product. People can get literally sort of hours worth of being paid to use energy. For free electricity, that's a bit more of a targeted thing, but we've run 3 free electricity sessions already this summer, and we're planning to do more.
Mm-hmm. Interesting. So the key technologies that are enabling this, smart meters you've already mentioned, but there are other things that you can, intelligent energy systems that you can connect. Tell us about those.
So we also have in our product suite products for customers who have low carbon technology in their homes. So that might be a customer has a electric vehicle, a heat pump, solar and storage. These devices that are big sources of energy consumption that are electrifying transport or heat. What we have done is we've built a product called Intelligent Octopus that connects and speaks directly to the EV or to the heat pump and can help automatically shift around some of that consumption in response to prices. So We have a product whereby a customer connects their electric vehicle. They let us know, I need it fully charged by 8 a.m. tomorrow morning. And we'll always make sure that their EV is fully charged. But we'll find the lowest cost periods overnight to charge that EV. And this can translate into customer savings of, some customers will be saving £500 a year on their EV driving versus a flat standard rate tariff.
And for heat pumps, would these customers find that when there's a peak demand, their heat pump gets switched on and you can generate electricity from these devices without being in control of it?
For heat pumps, what we're very, very conscious of is, people need to, there's a comfort envelope where people need to be warm, but not too warm. And, so people generally tell us where they like the temperature of their home to be. And we do thermal modeling in the background to make sure that their temperature always stays between those limits. But what that means is we always follow that constraint. But within that constraint, we can, for instance, preheat the home. So you might switch the heat pump on ahead of a peak period, during some colder weather to get the home a little bit warmer. And then during that kind of constraint period, perhaps you turn it down a little bit. And the customer won't notice the difference. Like the home will still be warm. It's just that the heat pump isn't using. You've shifted that heat pump's energy use outside of that target period.
So the customers have to outsource a certain amount of control of their home appliances to a certain extent to Octopus, and presumably they can take over whenever they like as well. Can they override if they need to?
So the customer can always step in. If someone needs to run to the shops and they need a bit of EV charge, they can override. If the home gets too cold or too warm, they can override. So the customer's always in control.
And how far does this automation go? I mean, say, for example, you want to do the washing, you put all your washing in there, but you want to wait for the best time, the most energy efficient time to do it. Are those kinds of devices, is that kind of control possible that Octopus will say, okay, 2:00 in the morning, we're going to switch it on and it'll be ready by the time you get up?
We're not doing washing machines yet. Washing machines are already very efficient. Appliances are generally quite energy efficient devices. But what we're looking at is the big sources of energy use in the home, which are also the things that are driving a large portion of costs on the bill. So I mentioned electric vehicles, heat pumps, battery, solar and storage if people have those. I mean, we recently launched another product which is called Snug Octopus. And this is for people who have storage heaters in their homes. So basically, for people who aren't familiar, a storage heater is basically you have a thermal store, which could be something like as simple as having some bricks, kind of within the storage heater. You heat it up hours in advance, and then over the course of the day, it kind of gently releases that heat. This is very old technology. It's very non-digital technology. But we've released a product where we can talk to the storage heater using people's smart meters, again, with permission and with like a very high level of kind of cybersecurity and, safety and all of that good stuff. And we have 600 customers who are currently on this Snug Octopus tariff. It's a sign that, participating in the energy revolution isn't just for people who are relatively well off in society. Lots of devices and technologies within the home can be made flexible, and we want to open up flexibility to any customer to participate in.
I know you've got a new partnership with the electric vehicle manufacturer BYD. You mentioned the vehicle-to-grid technology. Tell me a bit more about that and how that works.
If you have a regular electric vehicle, it's kind of one-way charging. So you charge up the vehicle, and then you go and drive it, and then the charge runs down, but essentially it's just energy inflowing into the home, into the vehicle. With vehicle to grid, that can go both ways. So you can use your vehicle to run to power your home, or to export energy back to the grid. So it works basically as kind of a battery, is a battery on wheels that you can use to drive to work, but it's kind of essentially a battery within the car. So last month, we announced a really exciting partnership with BYD, the electric vehicle manufacturer, where customers can get an electric vehicle lease, one of BYD's Dolphins. They can get the charger in their home, And then they can get all of the energy that they need to power that electric vehicle basically for zero cost. So if you drive more or less, it doesn't matter, you get one price. So all of that is available for £300 per month. So you get car charger and as much energy as you need to power the car, which is a really competitive rate, and customers can save hundreds of pounds versus if they were on standard variable tariffs or.
And the benefit for Octopus is that you can use that as part of the energy infrastructure. Is that right?
That's right. So what we will be doing is looking to use the battery to create value basically for the customer. So sending energy back into the grid when prices are high or when the grid is under stress. So that will join part of our big kind of virtual power plant of devices.
So the virtual power plant, I think, is a fascinating idea because we're used to these kind of single, massive industrial power plants that have generated that broadcast energy to the masses, and that is changing. The virtual power plant is something completely different. Tell us about how that has come to be and the challenges in creating and operating it.
Yeah, so the virtual power plant concept is, in the old world, you would have a big central power station that, with a control room and a bunch of guys, just sort of shoveling coal into the boilers and everything. What is possible to do now is we've created a digital virtual power plant where all of the flexible assets that I talked about, electric vehicles, batteries, V2G, heat and others, form a kind of distributed power plant where you can adjust the energy consumption of this fleet, at a grand scale. So, for instance, we have 300,000 devices that are connected into this virtual power plant. That's equivalent to about 2 gigawatts of demand, which is bigger than almost any other power station in the whole of the UK. And what that means is, so for an individual customer, the customer will get their EV charged or they'll have their home be warmed. But in the background, we can coordinate across all of these hundreds of thousands of devices and run that to provide energy back to the grid or reduce energy consumption or turn energy consumption up. So we're able to use the consumption side almost as a power resource that can help integrate renewables better and can create value for customers.
So one of the challenges of operating a power grid has always been connecting devices together in a way that makes them all work stably. If you've got hundreds of thousands of devices, what kind of challenges does that create for the grid?
I think that actually the way of doing this helps increase resilience and robustness for the grid. Because, if you have a lot of these devices or a lot more power consumption going into people's homes, and the grid can't see where it is, and the grid can't influence when that runs, then you risk putting a lot of stress on the existing network and infrastructure there. With the system that we have in place, we're able to, we've got better visibility on when all of this energy use is happening. And because it's distributed and decentralized, it means that there's just a lot more robustness in the system because you're not relying on a single point of failure that a big power station might be.
So when you say decentralized, is that decentralized control? You've obviously got an overview, a top-down overview, but in terms of controlling the grid, if you have a decentralized control, the possibility there is for quite complex behavior to emerge. Do you ever get that, or do you have to design it so that doesn't happen?
It definitely is a complex problem, and we have some very smart machine learning engineers who are working on exactly these types of problems. I think that what you're trying to solve is a very complicated optimization problem where you need to make sure that, if you want to make a kind of a change in power or a change in demand, say you want to adjust to follow a renewables pattern or something like that, you need to do that in a predictable way that also makes sure that all of the EVs are charged and all of the homes are warm. So you're kind of optimizing at the central level, and then you have to optimize at the distributed level and push all of this out. And what we've built together with the Kraken technology platform is a system that does all of this in real time, in live responding to grid signals, while meeting customer needs, while generating value for customers, but it does it in a completely automated way. So, and in that sense, we have more robustness and better security, than alternatives.
And how does that scale? Because these optimization algorithms are notorious for the way in which they scale, very demanding computationally. If you've got 100,000 people on board, it may work in one way. But if you get 1 million or 10 million, you may find that it doesn't scale linearly in terms of the complexity. Do you get a sense of how you're going to manage that as the problem gets bigger?
There are definitely some interesting data science challenges. I mean, to give you a sense of the scale so far, we launched a product back in January 2022 with a beta of about 600 people. And since then, so over the course of 3.5 years, it's grown from that to 300,000. So it has already grown through orders of magnitude. And by the way, that's sort of in the UK. It's also we're in France, Germany, Italy, Spain, the US, in several other markets as well. So scaling has been a problem that we have faced, and we have grown, and it's growing in a very rapid way. But that's something that we're kind of actively working on.
That's interesting. So one of the important factors in the stability of a grid is the way in which instability can spread. And we saw an example of this in Spain in June, where a huge part of the network went down very, very quickly. And in the aftermath, it was quite a complex event, this blackout in Spain. But in the aftermath, there were some studies that seemed to suggest that a surge had occurred, perhaps at a solar power plant in Spain. And that when surges occur, they can change the frequency of the grid, and then that can trigger a fail-safe, and then that itself creates other instabilities, and they cascade through the grid in a way that knocks one thing out after another. And what happened in Spain was that like 60% of the grid went offline in 5 seconds or so. It was a huge challenge for the operator there. But there are ways of using renewable energy in a way that is stable. Can you talk a little bit about that? Because I think it's fascinating how the stability is almost a kind of natural part of fossil fuel generation, but it has to be managed a little bit more carefully with renewable resources. Tell us first of all how the stability is maintained with an ordinary turbine.
Just to pick up on the Spain question, from my understanding from having a look at it and reading around, is that renewables in the first instance were not primarily responsible. There was a lot of kind of noise and maybe a bit of misinformation directly afterwards, but essentially the grid operator was not carrying enough voltage reserve. So voltage is one of the things that you need to keep in balance in order to keep the lights on. So they didn't have enough kind of voltage protection, which then, as you said, sort of things went out of limits. And then the interconnector between Spain and France cut off. And then at that point, you basically, the lights went out in most of the Iberian Peninsula. So I think that generally people who are looking at that problem, that was a grid management challenge or problem or failing rather than one that was specifically related to renewables or something like that. The role that intelligent Octopus and low carbon technology assets have to play is with the coordination and with essentially it's a route to better integrating renewables onto the system, because you have all of these assets can be really responsive to what's going on the grid. So if you have renewables kind of ticking up or ticking down, you're able to kind of raise and drop the level of device energy use in a smart way that in some ways rivals the ability of what the old generation of fossil fuels would be without pumping CO2 into the atmosphere. So because we have this advanced layer of controls and management, we're able to better respond to changes on the grid. And so that kind of increases the resilience and robustness of the system as a whole.
So how does this flexible, decentralized approach help us with our low carbon targets as a country?
Octopus has always been at the forefront of arguing for, low cost, low carbon energy transition and using technology to do that. And if you look at the approach of government and system operator and stuff like that. People are very serious about decarbonisation, but a lot of the focus for that goes on to renewables. And I think there are questions about, how you manage the system and how you can better integrate renewables that don't get as much attention. And what we're seeing is, I've already spoken about virtual power plants and the systems that we have. These are operating at scale and they have a huge role to play in the grid. But what, unfortunately, the markets and the rules are set up for the old forms of generation still. And there really isn't as much openness on the market basis as there should be for smarter forms of demand. So one thing that we're calling on government and the system operator to do is to place much more focus on the flexibility side of things and to treat this as a resource similar to a gas power station that can really be used to kind of manage the grid.
So what do policymakers need to do to make that happen?
So there are a range of different levels of technical detail you could go into here. What I might do is bore people about final consumption levies for a moment. So essentially, the price of electricity in the UK has a number of components in it. So one is the underlying cost of energy, but then a lot of policy cost and a lot of other system expenses are layered on top of that energy price. So that means that even if the energy price goes negative, you still have to pay all of these policy costs and taxation and other bits and pieces. And when you look at the gas price, gas doesn't have anywhere near the same level of levies that are put on top of it. If you want to make flexibility really competitive and unlock it at scale, today, we really need to remove as many of those costs as possible or rebalance them across electricity and gas. And that would mean that when the underlying price of energy goes negative, then the customer could truly see a price that was negative as well. So it's intervention. I think that's one specific one. On the whole, we need to just look across and see the value and the potential value that's being generated by flexibility and flexible technologies and enable them to compete on a level playing field with gas and other forms of generation.
And does that extend to business as well? Because the cost of power is a big factor for many businesses, isn't it?
That's right. Yeah. I mean, the story is absolutely true for business too. I mean, one thing that Octopus was fighting for was something called locational pricing, where if you live near a wind turbine, and the wind turbine is blowing, you get a lower cost of energy. Part of the reasoning is because there is so much wind production in Scotland. Occasionally, there's more wind production in Scotland than the grid can take. So wind generation is getting paid to turn off, and then you're paying gas in another part of the country to turn on to cover the difference. Now, the perfect solution to Octopus's mind is if you were able to increase that variability of pricing, you could incentivize data centers to move to Scotland or different industries that are based on electricity to move to Scotland. Now, the government recently decided that they're not going to do that. They're not going to go with that approach, but we're still very actively thinking through and calling on ways to make pricing more flexible so that business customers can benefit as well as normal residents.
And what other ideas are you exploring? It sounds like there's a huge space of potential mechanisms for flexibility.
So we're spending time thinking through how to completely revolutionise what an energy company and a energy retailer is. One example of this is zero-built homes. So we are partnering with some of the UK's largest home builders to add low-carbon technology into new homes that are constructed, and to do it in such a way that we, as an energy company, are able to offer energy completely free to the home. So with some of these new home designs, if the homes are designed in the right way, designed to spec, if they include solar, energy storage, and a heat pump, and they do that in the right configuration, that means that we as Octopus can come in and give a guarantee to that new home for zero bills, zero cost of energy for 5 years. So this applies to some new homes that we're working with some of the major house builders to deploy, and we're able to kind of give that guarantee to some customers.
I mean, how do the house builders respond to this? I mean, because you think, well, who wouldn't want free energy like this? But you've got to source the equipment, make sure it's available at the right time to be put in. There are various logistical issues to work through. How is that being received by the house builders themselves?
There's lots of excitement, and I think it feeds into broader efforts for decarbonisation and increasing energy. And I think for a lot of house builders, it's really a differentiator. If you can build a property where the homeowner is going to walk in and they know that they're not going to pay anything for their energy prices, that's a very attractive offer.
Yeah, why would you build a house in a different way ever again?
Totally.
Yeah, that's interesting. We're coming to the end of the podcast here, and what I wanted to ask you is about the takeaway points that people should have about their place in this energy future, because in the past we've been kind of passive in our interaction with the energy world, but that is changing in a very dramatic way. How should people think about their role in this energy future from now on?
We're at a really exciting time. We've seen massive strides taken in renewables and, the diffusion of lots of this low carbon technology. The thing is, this isn't kind of the energy future. A lot of this stuff is here today. So, making your heat electric with heat pumps. Octopus has a heat pump called the Cozy that we manufacture ourselves. Making your transport electric as well and low carbon, this is all possible today. Within a very short space of time, we'll have the first vehicle to grid vehicle from BYD kind of out rolling on the road. So the future of energy is now. People can participate and can make their energy consumption flexible. There are already something like 2 million Octopus customers who are benefiting from flexibility in some way. And it's a good deal for customers as well. Like across all of these different programs, on the Intelligent Octopus products, there's potential to save, hundreds of pounds a year versus other alternatives. So we're very serious about building an energy future that is cheaper and greener and uses technology to back that up. There are great deals out there for customers, but anyone who's remotely interested in this should be really excited because it's something that you don't have to wait for. You can participate in it today.
Kieron, thank you. I think that's about all we have time for today. A fascinating insight into our energy, not our energy future, our energy present. And thank you all for listening. You can find out more about our new energy infrastructure and the opportunities it offers at octopus.energy/New Scientist. And you can listen to this and other New Scientist stories from the edge of science wherever you get your podcasts.